So what I do next is I create this chart. Your chart may not be as colorful as mine. All you need is a quick sketch with these values in it, because these values are what we're going to need to use in order to build our access control list. So let's examine our story problem here. Allow 10.00.16 and 10.00.17 to communicate with the web server on TCP port 80 or with ICMP, meaning I want 16 and 17 to be able to access the web server and also be able to ping the web server. Additionally, I want to allow 10.0.0.128 to SSH to the web server and then deny all other traffic. Well, let's just start off. So the first one is saying allow 16 and 17 to communicate with the web server on TCP port 80. So let's start with that one. So permit or deny? Well, allow means that we want to permit some traffic. The protocol here is TCP. I explicitly state that because I want to allow access to the web server on port 80. Port 80 is HTTP, which means that we're going to be using TCP at the transport layer. My source IP address here is going to be 10.0.0.16 with that wildcard mask of 0.0.0.1, which we discovered how to use in the previous module. The source port here. Well, a source port for our workstation is going to be an ephemeral port, and we're not going to know what that port number is. And if we leave the port number field blank in our configuration, we can select any source port address here, which is what we would like to do because our workstation is going to choose that source port for us. We have no idea what it's going to be. We might have an idea of what range it will be in, but ultimately we really just don't know what that source port is. So we're not going to worry about filtering on that. We're going to allow the source port to be anything. The destination IP address is the IP address of our web server, and the destination port number here is pretty easy. It's port 80. So our packet and segment are going to have these characteristics as it travels through the router from the left-hand network going to the right-hand network of the web server. Let's go to our next line here where we're trying to allow ICMP for the same devices. So once again, I'm going to put a permit statement there because I want to allow that traffic. This time the protocol isn't going to be TCP though, it's going to be ICMP, which is a layer 3 protocol. The layer 3 protocol information is important because ICMP is going to have a packet with a source IP address. So our source IP address here is exactly the same as our previous statement, allowing 10.0.0.16 and 17 as the source IP address. But now we do not even have an option to put in a source port number. Why not? Well, ICMP does not use TCP or UDP. So because it doesn't use that layer 4 protocol, there is no port number. So we can't even specify one if we wanted to. Our destination IP address is our web server at 192.168.10.10, and we also do not have a destination port number. So this rule will now allow traffic from 10.0.0.16 or 17 to ping 192.168.10.10. Next, we're going to allow access from 10.0.0.128 to SSH to the web server. Well, SSH uses TCP as a transport layer protocol, so I'm going to have to specify once again TCP is my transport layer protocol. My source address is going to be 10.0.0.128. I have no idea what the source port is going to be, so I'm going to allow anything. My destination address is 192.168.10.10, and then my destination port here is the port number of SSH, which I didn't tell you in the story problem, but if we look that up, SSH has a destination port number of 22. So there's our third line of our ACL, and then our last line here says deny all other traffic. This might get a little bit tricky because all other traffic seems ambiguous, but it's not. So the way I create that deny statement for all other traffic is I say deny IP as my protocol with any source address, any destination address. So if it doesn't match those 3 permit statements, I'm going to send it down to that 4th line, which is to deny everything. And what this means is that the list is hierarchical. The first line has more priority than the last line, meaning that when a packet comes into our interface, we're going to check to see if it matches the first line first, the second line second, the third line third, and then the 4th line last. So here, if it doesn't match the first 3 lines, we're going to deny the message. Now, why did I pick IP there and not UDP or ICMP or TCP? Well, if we go back to our protocol hierarchy, if I deny an IP message, What that means is that I'm also going to be denying ICMP because all ICMP messages must use IP. We're going to deny all TCP messages because all TCP messages must use IP. We're going to deny all UDP messages because all UDP messages must use IP, which means also that all of our application layer protocols are also denied. So when I use the statement deny IP any, what I'm saying is deny everything that's coming into the device that's in an IP packet header, which means that ICMP, TCP, and UDP are all going to be denied. If I just specify TCP, then I only have TCP protocols that are going to be denied, and I'm going to allow IP, ICMP, and UDP protocols. The same is true with any other combination here. So the hierarchy is important. We need to know that IP packets carry ICMP messages, TCP segments, and UDP segments.